Okay, so we are going to solve logarithmic equations, and we'll see in this section that we'll have three types of equations. Now, I've called it type 1 that we're going to solve in this video. That's just my designation. Realize if you look at another textbook, they might not have a type or anything. That's just for us to refer to. So I'm going to call this type of equation type 1. Where we have logarithms on one side and a number on the other. So let's notice right here, we've got logarithms on the left side, but on the right side, there's just a number by itself. All right. Or anything where we can move it so that there's logarithms on one side and then there's a number solely by itself on the other side, we'll have a type 1 equation. And when we do that, we're going to do 4 steps. We're going to pull these logarithms that are on this one side together into a single logarithm using our properties. Then we're going to use the circular rewrite we learned when we were talking about how to solve a logarithm itself, when we were talking about the very definition of a logarithm. Then we're going to end up with a normal equation that we'll solve. And then we do have to check because sometimes we end up with an extraneous solution that doesn't work because we can't have a zero or a negative number behind a logarithm. All right, so let's take this through this one right here through these 4 steps so we can understand what these steps are saying. All right, so first, pull the logarithms together as a single log. So on the left side, we have 2 logarithms being added together. Let's remember that addition, when we pull it together, goes back to a single log with multiplication. So I'm going to go ahead and pull this together as one single logarithm. And my addition is going to change into the insides being multiplied. So the x is going to be multiplied times the x minus 2. All right, now if I want to, I can go ahead and do that multiplication right now, or I can do it after the fact. It doesn't really matter. So I'll go ahead and do it right now. So I've got x squared minus 2x right there if I multiply that x through. All right. Now, let's go to our circular rewrite. Let's recall that circular rewrite we did before. We went 2 to the 3rd power equals this stuff right here. So 2 to the 3rd power equals all of the stuff behind the log. All right, now let's multiply out 2 to the 3rd. 2 to the 3rd is 2 times 2 times 2, which is really 8. And notice that what we've got now is a quadratic equation that we can solve in a normal way. So let's solve this quadratic equation. First, let's get the 8 over to the right side, and then we can factor it. So when I move the 8 across the equal sign, it's going to become a negative 8. And that is nice and factorable. And on a test, I'm going to give you things that do factor. All right, so this will factor as factors of negative 8 that add to negative 2 will be x minus 4 and x plus 2. Set both of those to 0. And we're going to get 2 solutions, but we're going to find that one of them is probably not a good solution. So this one gives us a positive 4, and this one gives us a negative 2. Well, let's go back. Our last step is to check and make sure that we don't have a negative sitting behind a logarithm. So if we check the 4, and we go back to the original, putting a 4 right here is okay, and then 4 minus 2 right here is okay. But if we think about this negative 2, this gives me a negative 2 behind this logarithm, and we cannot have a 0 or a negative behind a logarithm. If you try to just put a negative into your calculator, if you have like log of negative 2, you'll see that it'll give you some sort of domain error type message because that's not in the domain of a logarithm. So this negative 2 is not a solution, but the 4 is perfectly fine. All right, so let's take a second example through the process. All right, so here's an equation. Let's notice that it is type 1 because on one side of the equation we have logarithms, but on the other side we just have a number. So let's go ahead and do our first step. Let's bring these logarithms together as a single logarithm. Now remember that a minus sign means that this is going to come back as a fraction. It's going to come back as division. So I'm going to rewrite my log. When I change this into a single log, this one is going to be x minus 4 on top, whereas the minus sign is going to put the x plus 2 on the bottom. So remember, subtraction goes back into a single logarithm as division or as a fraction. All right, now let's use our circular rewrite. So we're going to say 3 to the second power equals this stuff. 3 squared equals this stuff. All right, let's go ahead and square our 3. 3 squared is 9. And now we have a normal equation. It's been a while since we've solved equations that involved fractions, but we did do that during the first week of class. And let's remember, to solve an equation involving a fraction, we multiply by the denominator to get rid of it. So let's multiply this side by x plus 2, and then let's multiply over here by x plus 2. On this side, our x plus 2's will cancel. Over here, though, let's distribute the 9. We'll have 9x plus 18. And over here, we just have the x minus 4 left. And let's continue solving. So let's subtract x and get our x's together. So that'll give me 8x plus 18. I still have this negative 4. And then let's subtract our 18. And that's going to give me 8x equals negative 22. And then divide out our 8. Now let's reduce this fraction. We get 2 goes into the top, negative 11 times, and into the bottom 4 times. All right, so our solution is negative 11/4, but remember we've got to check and make sure that doesn't give us a 0 behind one of the logs. Okay, so, or a negative number behind one of the logs. So negative 11/4. If we put it right here, we'll have negative 11/4 minus 4. Now, I don't really care what that answer is. I just know that it's negative because I've got 2 negatives there. So it's negative. That means I can't have this answer. So all that work, we cross this out. This has no solution because we didn't have 2 solutions and eliminate one of them. We eliminated the only solution that we had. So there is no solution. And we'll see that happen quite frequently when dealing with these logarithms, that we get a negative, the negative will not work. Now, just don't assume that just because it's a negative, it won't work, because if this had been a plus 4, then when we'd added the negative to the plus 4, we still would have had a positive behind this logarithm. But because it's a minus 4, we end up with a negative, and so that's no solution.